All right, you guys. So our last example is going to be on Newton's law of cooling. So take a moment and just read this. And then when you're done reading this, remember you want to figure out what are the points that they're giving you. And in this situation, it is talking about time and temperature because it's Newton's law of cooling. And what are the 2 points they provide and which point do they want you to find? Well, it is given to you that when the temperature is at 0 degrees, or I'm sorry, when the time is at 0, your initial temperature, which is the core temperature of the object, is at 1500 degrees Fahrenheit. And then after, one hour later, so this is in hours, and the temperature is in Fahrenheit. I just like to label things so that way I know what unit I'm using for the answer. 1 hour later, the core temperature went down to 1120 degrees Fahrenheit. Find the core temperature 5 hours later, okay? So it's very similar to examples 1 and 2 that we went over from the textbook. So looking at this, your dy over dt is equal to k times when the object is removed from the furnace and placed in a constant 80 degrees, okay? So that's going to be your y minus 80 degrees. Let's go ahead and separate the dy over dx. Dividing by the y minus 80 on both sides, y minus 80 is on the left, multiplied by dt on both sides, k times dt is on the right. Then let's go ahead and integrate this. Integral of this, remember, you're going to have to use a u substitution. So let u be y minus 80. du is just going to be 1 dt. Or I'm sorry, it's not a dt, it's a dy. Just kidding. dy. Okay, and so then if I were to replace this, I will have an integral. dy is replaced by a du over u. So this is just like having an integral of 1 over u, which is ln u, and ln u is y minus 80, there we go, equals, taking a look at the right side, the integral of k is going to be kt plus c. Now, my goal here is to solve for y, so let's put an e on both sides. So then I have y minus 80 equals ce to the kt. Add the 80 on both sides. You should have y equals ce to the kt plus 80. But I am given that my first point here, I'm going to use to find c. So let's go ahead and plug everything in. I'm actually going to keep and use the first equation there because my goal here is to find c, so it doesn't make any sense to put the 80 to the right side because ultimately I'm just going to move it over to the left again. So my y is 1500 minus 80 equals ce to the k times 0. This entire thing just becomes a 1, and c is just equal to 1500 minus 80, which gives you a 1420. Now that I have that, let's go ahead and rewrite my equation. So if I would rewrite equation, y minus 80 equals 1420 e to the kt. Now let's use the second equation to find k. So y minus 1120 minus 80 equals 1420 e to the kt. 1120 minus 80 is 1040, divided by 1420 equals e to the kt. So once I go ahead and divide it by this, 1040 divided by 1420 is a 0.7324. Now you want to get rid of the e, so let's do an ln. So ln e cancels, k, and you know what, I forgot to put the t in there, so sorry, that was my bad. So k times 1, there we go. So it's just k, I guess. There we go. Yeah. So e is gone. K is equal to ln 0.7324. So then I'm completed my equation, which is just y minus 80 is equal to 1420 e to the ln 0.7324 t. Now, your last question here says, well, when t is equal to 5, what is this equal to? Well, in this situation, it's going to be y is equal to 1420 e to the ln 0.7324 times 5. Don't forget a plus 80. And if you plug that into your calculator, your temperature in 5 hours is going to go down to 379.247 degrees Fahrenheit. And that is your answer, you guys. All right, so to practice a little bit more on this topic, go to your Y guided notes in your packet for Week 9 Friday. Here I have a few additional examples from your textbook. I also have a link to the video access right here, so you're welcome to watch the video. We'll talk more about this as we get into Week 10. As always, stay safe and healthy, and I'll see you guys next time. Take care.